let's take a look at how quickly and easily we can create scatter plots and find the linear regression equation in Pearson's correlation coefficient R using Excel. I'm going to use one of your homework examples from my stat lab to show you this so that I can show you how to get your data directly from my stat lab into Excel and then generate your scatter plot and your regression equation and your correlation coefficient R so that you'll see how this will work within your assignment. So for number 9 in your homework, what they're showing you is how to generate the correlation between the hours studied and the score that a student gets on a test. Now we know generally that the more you study, the better your score will be on the test. But we can show this mathematically by how strong the correlation coefficient is. We should see a pretty strong positive correlation between these two values. The more a student studies, the greater score that they earn on the test. So let's just take a look and see how this looks mathematically. So when you're in my stat lab, what you want to do is click on this little box right here and it'll give you the option to copy the table. Now you have a couple different options. You can open it in StatCrunch, which is another program directly within my stat lab. You can copy it to your clipboard so that you can paste it wherever you want, or you can just open it directly in Excel. Now I already have Excel open, but I don't have a worksheet open, so you're just going to see it pop open over here on the right. So it's going to open in Excel. And what happens is this chart opens right over here in Excel. So I have the hours spent, which is my X variable, 1, 2, 3, 4, 4, and 5, and that matches right over here. And then I have my test scores, which were 37, 42, 50, 51, 63, and 67. I always like to check to make sure that things match and that I didn't inadvertently get rotated into another problem, as that's happened to me before, and my numbers were off and I didn't notice that somehow different data had gotten translated over. So from here, I'm just a few clicks away from all the answers that I need. So what I want to do is I want to take my mouse and I want to click and drag and highlight all of these cells so that this is the data that I'm telling Excel that I want to work with. And then I want to click on Insert, and if you see, you should have all these graph choices up here. And one of them is a scatter plot. So you're going to click on Scatter, and you just want this first one right here, which is just your scatter plot with only markers. You just want to click on that. And look at that. Excel just generates a scatter plot for you. And it goes ahead and it puts everything on the right axis for you. And now you're ready to generate your regression equation and your regression line. And what Excel calls that is a trend line. So while you have your graph highlighted, and by highlighted it just means selected. That means it's the active item within your program. Right now our graph is active. It's what Excel is focusing on. It's not focusing on the worksheet. So if I were focusing on that cell right there, I would click on that cell. But I want to focus on this graph, so I'm going to click on that graph. I want to click on Layout. So if you look, you have other options here for the layout. If you come over here to the right, you have something called a trend line. Click on that and you'll see linear trend line, which we want linear trend line, but we want a few more options than just linear trend line. We want to come down to more trend line options, and let's click on that. We want linear trend line to be filled in, and then we want to tell Excel to give us our equation, and we want Excel to give us our R squared value on the chart. So from there, we can just click Close, and look, Excel gives us our linear equation of y equals 7.4154 plus 28.185. So what does that tell us? That tells us that we have a positive correlation and that our slope of the line is 7.4154 and that our y-intercept is 28.185. In other words, if our line were to keep going, it would cross this y-axis right here at 28.185, which is about right here, and you could see if this line extended, that's about where it would cross. Now our r squared value is 0.8821, but our correlation coefficient is just the variable r, so we would need to take the square root of r squared in order to get our correlation coefficient. So our correlation coefficient is going to be the square root of 0.8821, which equals 0.939. So that tells us that there is a pretty strong linear correlation between these two values. There is a pretty strong correlation between the hours spent studying and the test score that is earned. So let's go ahead and just plug these values in here and see if we're correct. So the slope that we're given here, and it says to go to 3 decimal places, would be 7.415, and the y-intercept is 28.185. And let's check our answer. Yay, we got that right. All right, and then let's pick our graph. Well, we can see that it's a positive slope, so we know it's not A and we know it's not C. And we can see that it's not going to be B because our trend line goes through our points. We have 1 or 2 above and 1 below, and then some go right through our line. See how it goes right through? But if you look at graph B, all of the points are below the line, so it can't be that. It must be D. So let's check that. That one matches our graph. And then let's see what it asks us to do. In the next part, it asks us to predict some values, and that means what would we get on a test if we studied 3 hours? Notice how, let's see, if x equals 3, predict a test score of y. So even though 3 hours is one of the x values given in our chart up here, we want to just calculate that value based on our regression equation. So we can do that, and we can plug in any x value and see what the predicted value might be. So let's take a look and see what that would be. To use a prediction equation, you just take the equation and you say y equals, and you take your equation, 7.41, whoop, that was a 415, and here's your x right here, plus 28.185, and then instead of x right here, we want to replace that with whatever value we want to check to see what y we get to correlate with it. So instead of x, now we want to do that calculation with a 3 in there. 7.415 times 3 plus 28.185. And let's do that arithmetic. And we're going to get 22.245 here plus 28.185, and we get a final result of 50.43. And I believe that is one of our choices. 50.4 is one of the choices. So that's how you would use a prediction equation. So let me know if you have any questions on how to use Excel to calculate prediction equations, correlation coefficients, or scatterplots. In the event that you need to rearrange your data, if your x and your y's are not graphed properly, so if you have the wrong variable on the wrong axis, it's a very easy fix. So let's just say we wanted to reverse this just for a minute. What you would do is you would go to, you would right click on your graph and you would select data, and then you would go here to edit, and you would come down and you would change, you would delete here, you would delete your x values, and you would change where you want your x range. So let's say then you wanted it here, you would change it to there, and then if you wanted to change where your y values were read, then you would change it to over here, and see how that would change your graph completely. It would change everything. All right, so that's how you would change your data, but I don't want to keep those changes. I want to go back to my original work, but that's how you would change the data if you needed to.